All right, welcome back. Today we are going to talk about slope, slope of a line segment. Probably one of the most important ideas that you get in mathematics is the idea of slope. It's repeated in almost every math class that you see: algebra, geometry, algebra 2, trig, pre-calculus, and then you see it again in calculus. Half the school year rather of Calc 1 is the idea of understanding slope. So imagine you run, and here's a flat piece of land that you run on, and then as you keep running you encounter hills, and you go uphill, you go downhill, then it's back to flatlands, and back up to uphill, and downhill, and back to flatlands again. So clearly, as you run, if you run on flat land that has no slope or steepness, you want to think of slope as steepness. Well, if you had to give the slope value of something flat or horizontal, no slope, no steepness whatsoever, we'd say it has a slope of 0, right? But the further along you go, if you go uphill, well, that's going to have a steepness to it bigger than 0. If you had to assign it a value, for example, you would say, well, the slope here would be something like a 5 in slope value, right? And then as you go downhill this way, well, that's a whole lot easier to run downhill. It still has steepness, it's just kind of in the opposite direction as this original steepness. So that's why we say it has a slope value of negative something. Let's say, well, this is so much steep this way. Well, this is much more steeper downwards this way. So we'd say maybe it has a slope value of, let's say, -7. Relative to this, it's steeper downwards, right? And then you kind of hit this flat land again. So right at that moment there, it has a slope of 0. And then, well, we're back to an uphill portion right there. At that part, it has a slope of maybe 6, right? And then downhill again, maybe a slope of -8, and then right here a slope of 0, right? The one slope we did not talk about in this diagram is, well, what happens if you're running along here on the flat land, and then you have this skyscraper or this building. Look at this. There's no way we're going to be able to run up a vertical building. That makes no sense. So we say when things are vertical like this, straight up and down vertical, this has a slope that is, well, undefined. I mean, it is so steep that you practically can't run up it, so we say it's undefined. You can define how steep it is. It's undefined. So slope is 0. Flat horizontal lines have slopes of 0, and then you have everything in between that runs the gamut of a +5 slope. You can have a +1,000 slope, would be very, very steep, but it still, has some steepness to it, and negative sloping values, -7, etc. So steepness is all relative to varying spots along this run of ours. But it's an intuitive sense of what slope means to us. It's a steepness number attached to a line in math, right? Whether it's positively sloping, positive slope, upwards this way, left to right, horizontal, no slope, what's 0 slope, right? Notice I'm careful, I don't use no slope, that's different. Negatively sloping, and then undefined. Some books call that no slope. I haven't seen that in a while, but just be aware it's out there. We usually identify that as undefined. All right. And today we want to be able to calculate slope. M. And we'll talk later, maybe, if we have time, about why they use the letter M for slope. You would think you would use the letter S, but they use the letter M for slope. And you always calculate the slope between 2 points, A and B. whatever variables you want to use, that's fine, A and B, B and C, etc. And to help us out with that, we'll use our XY grid to help us out with slope. I need to find my overhead marker. Where did I put it? Alright, where did I put the overhead marker? Here's one. So they will ask us to find the slope between point A, which we'll say is at 2, 2, and then at point B, let's say we're at 5, 4. So here's the 2 points at point A, 2, 2. Here's point A, 5, 4. That's 2, 3, 4 is right there. There's point B, and if we connect the 2 points together, there's our line segment, AB. It has slope to it, we can see that. There's steepness, just by looking, it should be a positive slope, right? If you're running uphill, this is uphill, so positive. And then to calculate that slope, you can always build between 2 points on any line or line segment what I like to call a slope triangle. And the way we build a slope triangle is similar to our discussion previously of the distance formula. You just connect the 2 points together. There's our slope triangle. Makes a right angle, always like this. And then I measure the side lengths of each. Well, from here to here, that is 3 units, and from here to here it's 2 units. And when we do slope calculation, slope is always rise over run. Y over X. When we talk about rise, that's up or down, up or down. Up and down is always measured in the Y-axis, so that's why it's Y's on top. Run means the distance going horizontally. How far is the run? A run of carpet. A run is the distance this way, horizontally. So, and anytime we measure things horizontally, it's always with respect to the x-axis. Therefore, over x. Y over x. Y over x. Gotta burn that into your memory. It's not x over y. No, it's y is on top, x is on the bottom. So the slope of AB is equal to 2/3. It's 2 rises for every 3 runs. 2 to 3. We could just as easily built our slope triangle this way. On this side of the line segment, it doesn't matter as long as you have a right triangle that has a slope triangle to it. You'll see the measurements are the same. This measurement is 2, this measurement is 3. And again, if I build rise over run, 2 over 3. So typically I just build it underneath the line, but it doesn't matter where you build your slope triangle, as long as you connect 2 points on the line. You can pick any 2 points on the line, really, but we always pick nice, convenient values. There's a formula that formulates rise over run as a slope, and the formula for slope is always y2 minus y1 over x2 minus x1. Just y is on top, x is on the bottom, and that's for any 2 points that you're given x1, y1. So for example, let's call this one x1, y1, and then letter point B is x2, y2. And if I use my formula to calculate that, I'll write it over here. Well, the slope is y2 minus y1, so 4 minus 2 over x2 minus x1. x2 is 5 minus x1 is 2. We would get 4 minus 2 is 2 over 5 minus 2 is 3. And the slope is 2/3, which is the same thing I got on my slope triangle. The slope